good evening, everyone, and nice to see so many people here again tonight, and that's great. Really, I wanted to pick up on one of the themes of my previous talk and just explore it a wee bit further. And probably, as Stephen said, the talk's not going to be as long tonight because I'm really just focusing on one particular piece of what I talked about last time. But I want to touch on a few things that I said previously, first of all, and also to pick up again on some of the things that Scott Wham said to folks a couple of weeks ago, because I think all of that is quite important to the context of what I'm saying tonight. So I'm going to try and share my screen now and we'll kick off. Okay, is that, everybody can see the slide okay?
Yep.
Yep, good stuff. So hybrid zero carbon church heating options. And I've got my contact details on there just in case anyone's looking for them. The structure of the talk is brief introduction. Then I'm going to cover what I said last time again, very briefly, what ideally needs to change by 2030. I'm going to talk very briefly about insulation and draft proofing because I think that's important to the context of what I'm saying tonight, and it's really to reinforce what Scott Wham said a couple of weeks ago. I want to make some background comments again, which are all to do with context and some practical considerations in churches, and then I want to look at some typical hybrid heating options. So introduction, really just again to say what I do. I'm an independent consultant, but I've been doing work on behalf of the Church of Scotland for the last 20 odd years under the Better Heating Scheme, which is a scheme that the Church has operated since the mid-1970s. The scheme is open to all denominations, and recently, well, for many years I've been going to denominations other than the Church of Scotland, but in recent years I would say that's picked up quite a bit. So I really, at the moment, for example, I'm actively working on projects with the Scottish Episcopal Church, a couple of projects, and I've been working with the Roman Catholic Diocese of Motherwell as well quite a bit recently. If you want details of the Better Heating Scheme, Robert Lindores in the General Trustees office can provide that, and his contact details are there. And again, really just to say these are my views, they're not Church of Scotland views, so the Church may take a different view of some of the things I'm saying tonight, but this is what I think. What ideally needs to change by 2030? Well, we talked about this last time. Oil-fired heating needs to be phased out. Natural gas and LPG heating systems need to be phased out. And there are very few churches that use LPG heating, so we're really talking about natural gas. And in terms of direct electric heating, it would be better if that could be replaced wherever possible with renewable systems so that we're using less electricity and putting less demand on the grid. Insulation and draft proofing. Really, the whole thing comes down to the fact that what we need to try and do is reduce the demand to try and make our heating systems require less heating input in cold terms of the number of kilowatts that are required to heat the building. So I think it's really, really important, and we'll maybe understand the context of this a bit better later on in the discussion, but it's really important that we do whatever we can to improve insulation and reduce air infiltration, i.e. drafts into the buildings, because that's the way that we can reduce the amount of kilowatts that we have to put in, and that is going to make it a lot easier for us to get to zero carbon in practical terms. There really is no point in oversizing heating systems because heat losses haven't been adequately dealt with. They're going to be increased capital costs, and then also obviously you've got embedded carbon costs to consider for oversized, overspec heating systems. So reducing heating demand is really what we must do. And I've highlighted the point there. Reducing heating demand in this way might also allow conventional wet heating system to work adequately at lower temperatures. So that's really what I'm getting at. It may be possible if we can reduce heating demand successfully in church buildings that we can get a conventional existing system to work adequately at lower temperatures. And just a final point on insulation, do remember that inappropriate insulation can cause major problems in churches. I've been to a couple of churches where badly installed roof insulation caused serious rot problems, tens of thousands of pounds worth of bills. So it's very important that it's done professionally and that you get professional advice in terms of particularly ventilation of roof spaces. So consult a building surveyor or an architect to get advice when you're looking at insulation. Okay. Just another thing on the same vein, it's not on the slides, but really it's something else that Scott Wham said. It's quite important to make sure that you tailor the use of your buildings to what the heating systems and insulation can cope with. So if you do have a huge sanctuary that you don't need to use in the middle of winter, and you've got a side chapel that you can use in heat, or a hall that you can use in heat, or if you're, as many churches are now, a church with several church buildings, then perhaps you decide that a particular building is not used between November and March for worship. I know that's difficult. Sometimes people want to have Christmas services, and there can be funerals that have to be held in the church. But if you've got more than one church, then it's quite often possible to get around that. Okay, so just some pictures again. That some of these I showed you last time as well, but just for people that weren't there last time, so that you can see the kind of things I'm talking about. This is the outside bit of an air-to-air heat pump sitting on an A-listed church in Argyll. So just to stress that if you put it in the right place, it's possible to get permission, even in an A-listed church, to put heat pumps in. This is the inside bit in another church. This is an indoor floor-mounted heat pump unit, and another one that has actually gone in the place of a previous electric heater, actually. Okay, now some background comments. Again, this is just contextual stuff. I feel that engineers tend to design for midwinter weather. And I was reading an article about this in a journal a couple of weeks ago, and it is very true and has been for 40, 50 years. Engineers don't want to get caught out, they're cautious, and so they'll design for a design temperature normally of -4 in Scotland, and then they'll add 10% or 15% to their design. So I think it's maybe not a bad idea to design a baseload system that will cope for 80% of the heating season and use a 20% top up with electric direct heating. And that's really what I'm talking about in terms of hybrid heating options, using a couple of systems, in a church building, once you've dealt with the heat losses by doing the insulation. Sorry to labour the point. Environmental considerations should extend to the reuse and refurbishing of existing systems where possible. And there are also often aesthetic reasons for taking this approach in churches, e.g. ornate old cast iron radiators. When I'm working in churches, I always try, where possible, to reuse nice bits of the heating system that I think will work. So old cast iron radiators look great, can be flushed out and reconnected very often. It's a bit of a difficult one for the heating contractors, because they always end up having different connection sizes from modern heating systems, and they toil to get the right fittings, but normally it can be done. Heating systems in church galleries also often make quite a substantial contribution to heating in the building and can often be left in place and reused. So quite often churches are looking to take pews out and really to reform the ground floor of the building. But especially in churches with larger galleries, L-shaped galleries, three-sided galleries, then you often find that there are quite a lot of radiators along the external walls. And people are generally not taking pews out in galleries. The galleries tend to be left and very often not touched. So it's quite possible that the heating system there can be left not touched and then reconnected. So don't rush to rip a heating system out of a church gallery if you don't need to. Obviously, this is subject to existing systems being suitable for reuse, i.e. you don't have corroded pipework, and that can be checked by pressure testing. And obviously you would want to flush any old heating systems to get muck and debris out of them. Just again to say that if you have plans to remove pews on the ground floor, then this is an ideal opportunity to install underfloor heating. It works well with heat pumps, so it works well with renewable heating systems. And underfloor heating does have the advantage that it provides heat at people's feet where they feel the benefit of it. And so people will generally tolerate a lower air temperature if there's some radiant heat at their feet. So from an energy saving point of view, underfloor heating is quite a good thing to do as well. Just something I thought of recently, with us all moving away from fossil fuels, there's going to be a big demand on electrical supplies throughout the country and a big demand on the grid, and you know, people are aware of this and there are concerns about this. If you presently have a small single phase supply in your church, then even if you don't have any immediate plans to make any changes, it might be worth thinking about upgrading to a larger supply now. Bit of a selfish thing to do perhaps, but in the end of the day, if you get in now and get a 3-phase supply in or get a decent sized supply into your building, then you'll be able to get rid of your gas-fired boiler plant or your oil-fired heating, and you'll be able to upgrade to a renewable form of heating because you'll have adequate power to do it. And you might find that in 5 years' time, you can still get the bigger supply, but in order to achieve that, the supply authority is going to have to increase the size of a cable somewhere, and they're going to expect you to pay for that. So it's not a daft thing to have a look at what kind of power supply you've got now and think about the future in terms of that. Just another point I made last time actually, if you do have a heat pump with direct electric heaters, so some kind of hybrid heating system I'm going to talk about later, then good idea to isolate the direct electric heaters in the milder months so they can't be left on accidentally. And the next one is really the point that I made earlier on in the presentation. If you do have a large church and it's possible to worship somewhere else in very cold weather, then you should look at that. Okay. Next slide. So here's a hybrid heating option for a typical urban church. Presently heated by a gas-fired boiler with exposed pipes and radiators. Very kind of typical scheme that we see throughout the country. So first of all, you'd want to improve the insulation as much as possible. Then you would want to take out the boiler plant and install heat pumps, or which could be air source or ground source heat pumps, and perhaps keeping the existing pipes and radiators if you're able to. You could consider adding some PV panels to the roof if that's practical and affordable. And then really you need to take stock and see where you've got to. So if by improving the insulation you had managed to reduce the heat losses substantially, you might find that with a new heat pump, although you were only able to heat the radiators to 55 or 60 degrees C, that the building would cope reasonably well. You might have longer preheat times, you might have to run the system a bit longer, but you might find that without ripping out and throwing the baby out with the bathwater, you were able actually to keep your existing heating system. And obviously that would be a good thing to do from a resource point of view. And if you find that you don't, that you're not able to cope, you might not be able to cope in the church, you might not be able to cope in one of the halls, although that's probably less likely because halls are generally easier to insulate. But if you're not able to cope, then you could use some electric radiant heating for cold weather top up only. And that's really what I'm considering the hybrid heating option. So the electric radiant heating might then only be used immediately before the service and for the time of the church service, and they might only be used maybe, if you're lucky, December, January, February. So maybe 12 times a year plus funerals. So really, that's a relatively cheap way of installing some additional heating that is electric in nature, and that will allow you this top up. If you don't fancy, or aesthetically it's not possible or practical to put in electric radiant heating, then another option would be electric convector heaters for the top up. These could be around the walls, but if you still got your pews, it would be better if they were under pew heaters. And I'll show you a picture of a modern under pew heater at the end of the talk. Under pew heaters are not really, we're not really talking about old greenhouse style tubular heaters anymore, because there's surface temperature issues with them. So you need to have guards, and they're really old hat now. So you would maybe look at a more modern pew heater if that was your option for top up. And again, you would really just be looking at putting that on shortly before and during the service. And I sometimes say to churches, well, you would maybe stick, if you're putting pew heating in, stick them all in the front pews so that folk have to sit together at the front of the church, and you'll be very unpopular. Plan for a typical urban church too. So the same thing again, a church that's heated by a gas-fired boiler with exposed pipes and radiators at the moment. So really just what I said before, improve the insulation, take out the existing boiler plant, but in this case, take out the heating system as well. So I'm now talking about a case where you feel that you can't reuse your heating system for some reason. Maybe the heating system is just past it, or maybe you're in the situation where you're wanting to change the configuration of the building too much, and it's very difficult to reconfigure the heating system. So in this situation, then a good cheap option would be to install, well, when I say cheap, relatively cheap, would be to install air-to-air heat pumps to cover the base load. That's going to be less expensive than putting in an air-to-water system or a ground source system. And again, you could consider some PV if practical and affordable. And you don't need to size this air-to-air system to cover the entire load of the building. Again, why not go for the old 80-20 rule? You know, try to get the system to provide 80% of what you need, and use some top-up electric direct heating for the 12 Sundays in the year that you require it. Now, I'm cheating a wee bit here because obviously I'm not really talking about halls as well, and clearly halls, lots of church halls are used 7 days a week, you know, morning, evening, and afternoon. So in the halls, if the top-up heating is going to be more frequently required, then it would make more sense to have the heat pump size more generously so that it can deal with the entire load after you've dealt with the insulation. I'm sure you're all getting very bored of me saying that. And here's one for a country church, currently heated by electric tubular heaters, as many of them are. Improve the insulation as much as possible, install heat pumps to cover the base load, add some PV if practical and affordable, and then again use some electric radiant heating or convector heating for cold weather top up. This could be existing tubular heaters in some cases. So if you've got existing tubular heaters that you don't need to rip out, and you've got guards on them from a health and safety point of view, then they do go on forever. You know, I go to churches where the tubular heaters are 60 years old sometimes, and they're still running. It's a resistive wire element in them, so either they work or they don't work. So if they electrically test okay and you're happy with them, then they could be the form of top-up heating that you use. So the heat pumps would do the base load, but rather than chucking the baby out with the bathwater, you keep the tubular heaters and you use them for shorter periods. You might move them again to the pews at the front to encourage folk to sit in one area of the church. So that's that one. just some pictures now again for people who just want to get a feel for the kind of components that I'm talking about. This is the outdoor bit of an air-to-air heat pump at Duncan's Macintosh Church in Fort William. In this case, it was a B-listed building, and the planning department wanted the heat pump painted to a particular RAL code, a shade of grey, and that was the grey that they wanted. So it was done, and that allowed us to put it in that location. This is St Gerard's Church in Bells Hill, which I visited recently. And this is quite an interesting church. It's a 1970s church, relatively unusually with a suspended ceiling in it, but some churches do have that. Above the suspended ceiling, there's a metal deck roof. The suspended ceiling is getting old, so I think there are plans there perhaps to replace the suspended ceiling to improve the insulation above the suspended ceiling, which would help further reduce the heat losses. And that suspended ceiling is an ideal place to put electric radiant heating in. You can get electric radiant panels that fit in a 600 by 600 modular ceiling grid. So you can get, for example, an electric radiant panel that's 3 meters long, in other words, 5 tiles long, and could sit directly above some of the pews there. So some banks of electric radiant heaters could really easily be fitted in a church like that as top up if required. So in this church, I think there would be a really good chance that it be very practical to reuse the existing heating system, the existing wet system with a heat pump. Just in terms of timing for some of the things I'm talking about, I'm a fan of not using expensive air-to-water heat pumps. If you're looking at an air-to-water heat pump, I'd rather use something that's more like a mass-produced unit than something that's bespoke. And I think a lot more mass-produced units are going to come on the market. But at the moment, the main manufacturers are making the smaller monoblock heat pumps, which are the kind of cheaper type that basically you plug in the electricity to them, and you've got a hot water flow and return connection out the other end of them. So these types of heat pumps are generally only available kind of 14, 16 kilowatts at the moment. So if you've got a load in a church like this of maybe 50 or 60 kilowatts, then you have to piggyback maybe 3 or 4 of these pumps. So in terms of timing, at the moment, I would be doing the insulation stuff first. Makes sense anyway. If funds are limited, do the insulation bit first. Try and cut the heat losses down while you've still got your gas-fired system. And then in 2 or 3 years' time, hopefully when the market starts to get really hotting up a bit more for heat pumps, then there'll be more options. I would hope that maybe you can plug in a single unit that's mass-produced, easy to buy, well recognised, easily serviced. Because at the moment, for a single outdoor heat pump unit that does 14 or 16 kilowatts, you're probably talking about the same kind of price that you pay at the moment for an 80 or 100 kilowatt boiler. So if you if you have to buy 4 or 5 of them, then you're talking 5 times the cost of a boiler at the moment. So maybe do the insulation first and hang fire a wee bit and see what comes along over the next few years, if you're able to. Now, just to show you some examples of electric radiant heating that's been installed in churches. This isn't a church I was involved in, and I was given this courtesy of CES Lighting and electrical engineers who are installers working with Solray. Solray are a major supplier of radiant heating and have been for, I don't know how long, but certainly the entire time of my working career. They make low temperature hot water radiant heaters, which have been used in hospitals for years. But they also have done electric radiant heating systems for quite a long time. So you can see the electric radiant panels at the edge of the roof there. And apparently this has been quite a successful project. I think that looks okay because they blend in quite well there. This is more pictures from the same church. So you can see in the far left of the photograph the panels that we looked at in the last slide, and then you can see the brown panels that have been mounted against the roof timbers at high level there. I'm probably not thinking of something as extensive as that, because really all I'm talking about is something that would be a top up, because we really want to use renewable heating to keep the energy use down for most of most of the time. So I'm not thinking of something that would maybe be quite as extensive as that. But it's really to show you the aesthetics. This is an old system from a church up in the far north at Lairg in Sutherland. So these are probably 20, 30 years old, these radiant heaters. That's the only form of heating in this church. I think it works relatively well. They've had a problem with it in that the panels were painted to try and blend them in, because they came white, but the paint flaked, and so they get a problem with flaking paint. So that's something to watch if you ever think about doing that. But that's again just to show how high you can mount panels that will work. They don't emit any light, these radiant panels, and that type of panel is made by a firm called Frenger, and also made in Sweden by another supplier who've been selling them in the UK for probably 20 or 30 years. And really just to show you a modern pew heater. So that's a bespoke pew heater. Again, British made by a firm called BN Thermic. And these can be mounted on the floor under the pew or turned through 180 degrees to the compared to what I'm showing in that photograph. So they're suspended below the pew. And the advantage is that you don't have the surface temperature issues, and that you also get a greater heat output per length of pew than you get with tubular heaters. You only get about 60 watts a foot with tubular heaters, but you know these heaters can produce 4 or 5 times that amount of heat for a similar length. And that's the end of the presentation. Thanks very much. Stop sharing, and yep, thanks very much. So now I'm very happy to take questions.
Thank you very much, Andrew. We had quite a number of questions that were put in the chat. What we'll do, we'll take the chat questions first, and then we'll move on to people waving at us in case you want to ask a question by the traditional means of putting your hand up and somebody noticing you. So the first person who put a comment in was Mike Goss. Mike, I'm going to ask you if you can to unmute yourself, just to raise the questions that you put in initially.
Yeah, I was wondering about the draft proofing issue now that we're talking about trying to maintain airflows with COVID. So that was one of the issues that I think we're facing currently. Whether that is a longer term issue or not, I don't know, but it does seem to me that it could be a bit difficult trying to keep heat at the same time as keeping an airflow.
Mike, you're also with Barry linked with Carnoustie Parish, so I'm assuming you've got more than one building you're worrying about as well.
Oh yeah. Well, we've got one big building, which is Carnoustie's, which is C listed, which we're hoping Andrew's going to come and see actually quite soon. And that's got a big project planned for it. Pews out, underfloor heating in. So very interested in what you're saying about hybrid systems and the 80-20%, because that sounds like the kind of thing we should be looking at there. But also we have a very high ceiling in that. It's one of these arts and crafts 1902 buildings, very, very high ceiling, but there isn't really a ceiling. We see the underneath of the planks that are used for the slates right above us. So there's slates, one layer of wood, and that's it. So there's no real insulation up at the top, and that's plus there's 100 feet to go up to get up there to put any insulation. So there's issues there as well.
Okay, so well, going back to your question, Mike, I mean, that is a difficult one in terms of what we do about draft proofing. It's something that we should, in normal circumstances, be doing, and hopefully, you know, in a couple of years' time, we'll be back to that, and you know, we'll be able to treat church buildings in the way that we normally would. Ventilation in terms of fresh air supply in churches is never normally a problem, because the volume of the church is so great, and the number of people is nothing like that they were designed for normally. So it's not normally an issue. Somebody, Andy, there very helpfully flashed up a suggestion, which was you could install mechanical ventilation with heat recovery. I mean, that is a practical suggestion if in the long term we've got an ongoing issue with this. So you could have a heat pump ventilation system which provided tempered, which means air at room temperature, tempered air, and which had an extract system so that you got an air change rate, and which the extract system had heat recovery on it, so heat was recovered from the exhaust air. You lose a bit of efficiency in doing that. It would add capital cost to the system as well. So it's not something we would want to do, but I suppose that would be a practical suggestion if we've still got a COVID problem in a few years' time. But maybe at the moment, the sensible thing to do is concentrate on the insulation and not the draft proofing.
Okay, thank you. We've got the next questions from Trevor Garlick. Trevor, I think, is from one of our Gold Award winning congregations in Wardley Parish Church. So I hope you don't mind mentioning that, Trevor, but it shows that we're all learning in terms of the net zero carbon agenda. So are you able to unmute yourself, Trevor, to ask the question?
Yes, hopefully that's unmuted now.
Fantastic, thank you.
So my first question was about de-stratification. I noticed there was one of the churches in Dundee had put that in and claimed it was very successful. I also noticed the comment from somebody else about it causing downdrafts, but I know that you can get these with speed controllers for the fans, and suggestions that you turn them down, during the service. So I'm just wondering what the opinion was of these.
Yeah. So my experience over the years has been that churches that have de-stratification fans quite often don't use them because of complaints about drafts. They work quite well in church halls because people are not generally sedentary for an hour in a church hall. When people are moving around, they don't feel drafts as much. I think they're generally better in halls. Another advantage in halls is that if you don't have fixed seating, then if you've got something like that at high level that you have to maintain, it's easier to get safe access up to it to maintain it. If you've got them in churches at quite high level and you've got pews in place, then it can be really expensive and difficult to get access in if you ever have to get up to fix it. So that's the kind of stock answer. But I have also heard from some churches a positive experience. I was at a church in Murray maybe about a year ago now, where they had installed fans that worked in reverse. So they sucked the air up towards the roof, and then that blasted it onto the pitched roof, or moved it up onto the pitched roof, and it then seeped back down the walls again. And they seemed to feel that worked quite well. They did, however, have heating round the walls, which would have produced a thermal upcurrent, maybe to kind of combat it a bit. So I think the jury's out a bit. You can certainly use it before the service and reduce the fan speed, during the service if people do complain about drafts. The other thing is it's interesting to find out exactly what the temperature profile is in the church between ground level and roof level. I know of some churches where they've done detailed measurements and found that it's not as high as they would have thought. I've heard figures of 2 or 3 degrees centigrade talked about before.
It's something I'm going to intend measuring shortly.
Well, I heard of somebody that did it with a very long fishing rod many years ago, and that seemed to be a way of getting up to the roof and taking a measurement up there. So I think it's worth checking that just to see how bad the problem actually is as well.
Okay, thank you. My other question was about electric underfloor heating, actually. I know that's not using local renewables, but it's much cheaper to put in than a water-based underfloor system.
Yeah, I would just worry about that though, in terms of the fact that potentially you're using 5 times, you're using a fuel. Electricity is 15-16p a kilowatt hour. Gas is 3 at the moment. So if you put a heat pump in and it's got a coefficient of performance of 4, then you're maybe talking about 4 or 5 pence per kilowatt hour for the fuel, as opposed to 15p with electricity. So I think the running costs of an electric heating system could really run away with themselves. It would have to be very, very carefully monitored. And you would need to put in a certain size of installation. If you're putting it across the entire floor, then you'd probably find in a church it might be a 20 or 30 kilowatt installation. So
Yeah,
that could be using quite a bit of juice.
Yeah. I just didn't know if there was any other practical reasons why not to use it. I can't find out much information about it.
Really, the practical reason not to use it over the years has been the running costs before folks started getting concerned about, carbon emissions. Just because, compared to using a wet system from a gas-fired boiler, it's probably costing about five times as much per kilowatt hour, for the heat. And okay, the wet system is going to be a bit more expensive to install, but you might be surprised, how that it's maybe not as expensive as you think, because in the end of the day, the components that go into the wet system are really just insulation materials and plastic pipe. So it's whereas the electric floor system is going to have quite a lot of copper in it, which is probably going to be relatively expensive the way materials prices are going. So I think it'd be interesting to do a cost comparison as well on that. But my gut feeling is it might not be as high as you would think, or as much of a difference as you would think, rather.
Okay, thank you.
Our next questions come from John Collins. So John, I don't know, would you like to unmute and ask your own question?
Yeah, I've seen a few adverts which look really interesting for foam sprayed under a roof to stop drafts and obviously to stop heat loss. In the church I'm thinking of, rather than URC, that would work really well in the hall because it's got a ceiling below roof level. It wouldn't work in the church. And I'm just wondering if there's any disadvantages of this sprayed foam system.
I'm really not qualified to answer that question, John. I don't know, is the honest answer. That's more of a question for a building surveyor or an architect, really. I've not seen that product. Just something actually that you've touched on there that's made me think of this. That church that I showed you the slide of as well, St. Gerard's, that's a brick-built building from the 1970s. I mean, at the moment, you wouldn't probably have thought of putting cavity wall insulation in a church building if it was only used once or twice a week. But again, that's something that we could do, to try and reduce heat losses, in a church of that vintage if you've got a cavity. But maybe that's one for Scott Wham, or a building surveyor.
Yeah, thank you.
Thanks, John.
Our next question is from Elizabeth Oliver. Elizabeth, are you able to speak okay?
Yes, is that all right? Can you hear me?
Yes, thank you.
Thanks, Andrew. I just had one query about radiant heaters, because I was in a church had a church in Alexandria, and we're a bit like the church in the Highlands. We didn't have any other means of heating except for radiant heatings on the wall, not quite as high up as they were in that church because the ceiling wasn't so high. But the problem was, often you felt really hot. Your head was lovely and hot, but your feet were cold.
Absolutely. That's spot on. And that's absolutely the problem with that type of system. So, I would, 20 or 30 years ago, or 20 years ago, I would have been saying to you, if you put in a radiant system, put in some convection as well, so that you've maybe got tubular heaters under the pews and a radiant heating system at high level, so that you're warming the air a bit and you've got some heat down at low level. And now really what I'm saying is, we'll put in a heat pump for the convective bit to try and raise the air temperature a bit, and use the radiant heating just as a top up, rather as a main source of heating.
Thank you.
Pauline Jones also added the appearance as an issue in relation to those heaters as well, which can be a concern.
Absolutely, yeah.
Maybe less important than the safety one, but still important.
Yeah, very, very important. And I'll get into trouble with Carta and the Church of Scotland if I don't tell you to check, these things with Carta. Obviously, the last thing you want to do is put in something that looks awful, without getting permission, first of all.
I notice Alan Corbett's had his hand up. Would you like to unmute and ask your question? Sorry, you're still on mute at the moment.
Is that me now?
Yes, hello, Alan.
It's Alan Corbett from Stenhouse and Carr in Stenhouse. I know
Hello, Alan.
remember last year you came and gave us some advice to
Yes,
the old 70s boilers.
yes,
We eventually got prices and nothing's happened because of the local politics.
yep,
Apart from that, I've been looking at and reading in the papers about hydrogen boilers.
uh-huh,
And I spoke to the British gas engineer who reckons that most of the companies now, they can actually take a mixture of 20% hydrogen and natural gas.
mm-hmm,
And it won't be for another 20 years before we've actually got, you know, fully hydrogen boilers.
mm-hmm, mm-hmm.
The benefit is for society and the districts is, of course, you can use the existing gas mains for hydrogen.
Mm-hmm, mm-hmm.
But I mean, I don't know if you have any thoughts on that type of hybrid.
I think the problem is probably the timing here and the rollout of hydrogen and the extent to which it's going to be used, you know, for commercial and domestic heating systems.
Yes.
You know, we talked about this a wee bit last time, and the feedback that I got after that talk, and from other things that I've read in the press as well, is that hydrogen is perhaps going to be more likely to be used for or in areas where there are specific things that really you can't use things like heat pumps for. So the availability is a potential problem.
Yes.
I think. I mean, lots of companies are now producing boilers that are hydrogen ready. You know, so you know, the gas industry, as you would expect, is right behind it because you know they want to keep people using you know, the gas infrastructure.
Yes.
And the boiler companies are behind it as well because you know, obviously they want to keep selling boilers. But I just don't quite know where that's going at the moment, and I don't think honestly anybody does. Another very interesting thing that I saw in the press about a month ago was a large cylinder which was filled with thermal rock, very heavy cylinder.
Yes.
And this cylinder, basically, it was possible to heat electrically, a bit like you would heat an old-fashioned storage heater, but it would be heated electrically using smart meters so that it used electricity from the mains at cheap times. And it would be possible for this thermal mass then to store enough heat that a copper coil that ran through the middle of that could be used to extract it. And that the thermal mass was getting to a temperature of 500 centigrade, so very hot, enough to produce steam probably. So that's something that there's government funding for at the moment, and that's something that's quite interesting because that's something that could be a complete replacement for a gas-fired boiler in that it could comfortably produce heat, you know, at normal boiler temperatures, and would just be something that you would plug in electrically. So there's a lot happening at the moment, and again, that's a reason for doing the insulation bit now, and you know, kind of sitting back a wee bit on the heating bit if you've got the luxury of being able to do that, which I know in your situation you probably don't.
It's a full roof with no insulation at all, and it's a you know, it's a List A building with you know, important features. It's impossible to put a ceiling in to you know, for heat conservation. Unfortunately, too, we're just on the cusp of having to do something because the two boilers we've got are just they've just had it. So we're just in a position to do something now, you know.
Well, it may be in that situation that the sensible thing to do is to put in new boilers at this stage. I'd be happy to have another chat with you about that because you know, since I was at your church last year, even since last year, things have changed quite a lot. So you know, if you want to drop me an email, we could maybe have a phone call and just talk through the specifics again. And I'd be happy to do that.
I'll just mention that we also got prices for an electric boiler, but yeah, it was actually quite comparable. But SGN, they wanted about £8,000, £9,000 to run the cable around the church, because our supply comes in right at the other end of the building, and they won't allow us to put the three-phase cable to the new boiler through the building. It's got to go right round, and we've got to build the trench. We've got to dig the trench. They'll lay the cable and we'll refill it. So the whole process was going to be about 30,000 compared to the gas about 20,000. You know, so that was unfortunate. But it would have been great to do something electrical. Although I know it's more expensive running costs, but there's no flues and there's no gas problems and so on and so on.
Okay.
Thank you.
Well, thanks. Nice to talk to you.
Thank you, Alan. A lot of common issues people will find there as well. Next, we've got David Crippen from Crown Church in Inverness. Thanks, David. Can't quite hear you yet, David. I'll just read out your question for just now, but if you're able to jump back in with any follow-ups, it'll be okay. Is there any comment on modern infrared panel heaters as the top-up heating, Andrew?
So absolutely fine. Possibly better in church halls if they're infrared, because they don't tend to have the throw, to get down from high heights as some of the other types of electric radiant heaters do. So you might find that if you wanted to mount them on the wall at eaves level in a church, which might be 4 or 5 meters, that you weren't getting a lot of heat out of them down at ground level. So maybe for that reason, better in halls. Also, the light emissions, some churches don't like the fact that that there's a glow from them. Some people like that, but some people don't. Sometimes a heater that doesn't emit light is better in a church, a bit like the ones that I showed in the slides, where they maybe blend in a bit more, and they also can operate at quite a high level.
Our next question really comes from Bruce Mumford in the Carlisle Diocese. So Bruce, would you like to ask your own question?
Thank you very much indeed. And thank you for allowing me to come to this meeting from the other side of the border. But our problems are exactly the same as yours. Andrew, I've been talking to Valent recently. And the problem I have is the late Victorian 1880 church. A lot of them were built in Cumbria about that period. Paley and Austin, an architect you may have heard of, are responsible for a lot of them. They were all designed with coke boilers as the heating medium to heat up litres and litres of hot water, which went round the church using convection. Now, there is no chance of putting wall insulation. Roof insulation is very difficult because they're grade 2, it'll be grade B and grade A listed. So changing the interior with insulation products is a no-no at the moment. So the option which Valent have been talking about, whereby you would have a heat pump taking probably not 80% of the base load, but about 40 to 50%, maintaining the 12 degrees ambient, which Historic Scotland and Historic England both recommend. And then for services, you would then bump the heating up with the gas boiler to normal ambient temperatures. It's not terribly green, but what's your view on that?
Well, it's not super green, but it's fairly green, because in the end of the day, it's a compromise, and you're trying to do the vast majority of the work with the heat pump technology. So you're going to be using your boost really once a week potentially in a building like that for a relatively short period. So it's not ideal, but you know, you can't make an omelette without cracking eggs. So sometimes you just you have to make some compromises if it's really not possible to insulate your way out of the problem. And also maybe worth just kind of thinking about the product I mentioned earlier on. You know, the thermal mass cylinder. You know, if something like that appears soon, then that would potentially solve your problem.
I have to admit, I'd never heard of that.
Mm.
And I must
It was an article in the Times about a month ago, and I really should try and find it again. But it's something the government was putting money into as well. So, I mean, but who knows whether that will come to pass. But I think it just illustrates the general point that it's a fast-moving area at the moment, because things are changing so fast that the manufacturers are really trying to keep up. And I think that's going to be ever accelerating with COP26.
which makes churches very nervous of investing tens of thousands of pounds in a new scheme. And I think your advice, maximize your insulation, minimize your heat loss, and just sit back and wait and see what happens, is good advice.
Lots of churches take 2 or 3 years to get things moving anyway, so you know, why not use that time wisely at the moment.
Thank you, Andrew.
Thank you, Bruce. We're delighted you could join us across the border this evening, and some really interesting examples there for us to discuss. Next, we've got Carol McBride. Carol, you there okay?
Yes, I'm here. Can you hear me okay?
Thank you.
Hello there.
Hi. Similarly to what Bruce was saying, the church that I attend was built in 1850. It's stone built, but it also has the original stone interior. We have no insulation on the inside. When you look up into the roof, it's timber on the inside, so there's no possibility of insulation up there either.
Well, you're saying that, Carol, but I mean, sometimes churches have looked at insulating on the inside of the timber between the joists. So you need to get advice on that. And I've heard that you need to leave a wee bit of an air gap if you do that to avoid problems with the nails. But I think it might be possible to insulate on the inside of the sloping roof.
Okay.
You know, and that could be done aesthetically with, you know, maybe like a pre-insulated plasterboard that was a white finish, you know, so that you you know, that you ended up with something that looked okay. Putting a white roof in is good as well, from the point of view that you're going to reduce your lighting demand.
No, there would be no chance of that, because it's like timber effect, and the chances of getting people to agree that we could go away from that timber effect are just zero. We have trustees, and you know, they're very adamant that the internal appearance of the church must not be changed. And that lends itself to the problems of how do you get aesthetically pleasing heating units. So I've looked into everything that I could find as regards air source heat pumps and air-to-air source heat pumps. And the actual the units that would have to be installed internally just would look dreadful in the space that we've got. So the most recent thing that I've been looking at is the far infrared panels. We've always solely been electric, presumably after oil. I know there's an oil boiler underneath an oil tank underneath the church, but you know, that predates my time at this particular church. So we've always just used electric, and the heating that we have, not only is it expensive, it's not effective. So it's got nothing going for it.
What kind of heating do you have at the moment, Carol?
It's electric, how could I describe it? That there's no glow from it. It's down at floor level on the external walls. It runs along so that it's got a grill over it.
Right.
That on the rare occasions that it would actually get hot enough to burn people, they don't get burnt, sort of thing. But you know, I can have that on for 10 hours and there's no noticeable warmth in the church. And it costs a fortune.
Yeah, yeah. It sounds like some kind of electric convective system. Is a type of heating called Chuvec heaters. It sounds like something like that. I mean, to answer your question though, I mean, far infrared is maybe worth looking at, but you would just need to think a wee bit about what one of the other contributors said earlier on, in terms of the fact that radiant heating on its own can lead to kind of warm upper body and cold lower body. So it might be an idea to see if you couldn't somehow throw putting a couple of indoor air source heat pump units somewhere in the church that you could disguise them or hide them. And you know, you might find that it was possible to get a bit of heating like that in. For example, that church in Fort William that I showed the picture of the outdoor heat pump unit earlier on. The indoor units for that are wall mounted, but they're round the corner in the transept. So when you're in the body of the church, you don't see them. You would only actually see them if you were in the chancel. And so the church in that case felt that they could live with that. And the other thing is that they don't have to be white plastic boxes. You know, the manufacturers will customize them, you know, to any paint color that you want. So sometimes it's possible to disguise them a bit that way as well if you've got wood paneling, but you said you didn't. You've got stone walls.
No,
does make it more difficult.
The walls up to eaves height are all just stone, and of course it's very, very thick as well, which is another thing that when I've had engineers come out, they just look at the thickness of the walls and they say, oh, to drill anything through that's going to cost a fortune, sort of thing.
You know, I mean, a good solution in your case then, but probably a very expensive solution from your point of view, would be to put in air to water heat pumps with underfloor heating.
Well, our floor is all Victorian tiles, so there's absolutely no way to do anything with that.
I mean, the only way that you could do anything with that is you could maybe put a floor on top of the floor so that from a historic point of view, you weren't destroying the Victorian tiles and they were still there. But I mean, we're really kind of, we're struggling now.
Yeah. Our church gets used for quite a lot of weddings by people who have no association with the church. And one of the first things they say when they come in is, oh, what a fabulous floor. And then, oh, I'm glad you've still got pews. Yeah, I mean, I have looked at this really since just prior to lockdown started. And I haven't been able to come up with a method that we could use that involved renewables unless we got some ground mounted solar panels put within the church grounds that then negated some of our sort of carbon.
Where is your church, Carol?
It's at Dalmahoy near Edinburgh.
Right, I don't think I've been to that church.
It's on the A71, well, just off the A71.
Aye,
and
I know where
as
you
I
are.
say,
It's
it was built in 1850.
Sounds like a hard nut to crack, but if I think of anything, I'll let you know.
That would be fabulous. Thank you very much for that.
We're coming to Andy Maybury next. Andy's got a few questions in about different types of heating systems. Andy, would you like to ask away?
I mean, quick questions and comments. I mean, my experience is more on domestic stuff, but I have done work on larger buildings. Yeah, I agree, it's a huge challenge. Ventilation, I'm a great believer in heat recovery ventilation because it does turn things around and allow you to draft proof with impunity. But as you say, Andrew, for most church buildings, they're so large that getting adequate ventilation isn't a problem because you've got the volume there, and the sort of density of people is not an issue. But church halls, often there's more going on, smaller space, and where people are being active. And also a lot of buildings have extractor fans from the kitchen, from the toilets, and that's hot air being pumped out. If that can instead be routed into a heat recovery, then it means you're not losing that hot air, or not losing the heat from that hot air. But I made some comments also about heat batteries. I mean, storage is going to be such a key thing from now on in. And people think a lot of electric batteries, but they're very expensive. Storing heat is very much cheaper, as we discovered half a century or more ago with storage heaters and large domestic hot water cylinders with immersion heaters. Those are actually heat stores, and even on a lot of space heating boiler systems, there'll be a very large water tank as a heat store. But there's phase change materials which are used to hold heat. I've also come across the rock heat store that you mentioned, which takes it up to very high temperature, which again has its own challenges. Getting space for all these things is sometimes an issue, but if you've got an undercroft or an outhouse, then that's where you can put a large heat store.
Yeah.
Particularly if you've got a PV installation, the best way of using that is actually to run your heat pump or directly heat your heat store through the week, so that you've got the heat there to discharge into the building, ready for use.
Yeah, absolutely. I mean, that is a good type of electric hybrid heating, really, isn't it? Yeah, so effectively you can have a heat pump, but you can also use PV to store hot water in big buffer vessels. I mean, you've got the cost of that to consider in terms of the capital cost of the equipment, but it's certainly a practical way around some of the problems using technology that's available at the moment.
Mm-hmm.
And in terms of heat recovery, you're absolutely right. In church halls, there probably is a fair bit of scope for that. Where you have quite busy halls with large numbers of people in them, so the indoor air quality could be improved at the same time as recovering heat from the exhaust air, and using a heat pump to actually heat the heater battery. It is quite a good way of doing that. I was involved in a project in a hospital about probably over 10 years ago now, where we did that. Obviously the air streams were kept completely separate, so that the air was all fresh that was going into the building, and you were getting a good air change rate. But the heating wasn't done from boiler plant, as it would have been done in a hospital actually, but it was difficult in that particular building to get the boiler system to it. So that's why we put the heat pump in, and it was pretty expensive at that time, but it worked very well. So that is something that in some church halls might be applicable.
Mm-hmm.
Thank you. That's some useful thoughts. Thanks, Andy.
Thank you, Andy, and thanks for your posts in the chat as well. That was very helpful. Next, we've got James Watson. Thanks, James.
Hi, I'd just like to go back to hydrogen boilers. I've done a wee bit of research on them. There are two byproducts of the hydrogen boiler. One, it's an electrical generator. It's the way the gas is burnt into the hydrogen cell. It produces electricity. The other, it also produces copious amounts of hot water, which is ideal, as you all say, for underfloor heating. So, all things considered, it's got to be one of the best ways forward, the hydrogen boiler, because you're going to reduce your electricity greatly, and you're going to virtually get free hot water. I know you're going to have to pay a bit more for the gas, but
I think one of the problems that was identified after the last talk was that the actual amount of electricity that has to be used to produce the hydrogen can be pretty substantial, and so there are better ways of using that electricity, some people think, than to make hydrogen.
No, the boiler itself generates the electricity. We're not using the electricity to power the boiler. The boiler generates the electricity.
Aye, but the problem is, to make the hydrogen, you have to use quite a bit of electricity, which in itself could be used directly to heat the buildings. So that was one of the reasons that people that there's a fair bit of opinion that thinks that electricity should only be used to produce hydrogen where hydrogen is really the only practical fuel that could be used. That was some of the kind of feedback I got actually from a chap up in the northeast after the last meeting. I don't know if anybody else has got any views on that.
From what I've seen, there's a couple of problems with hydrogen. One is the transport of hydrogen through mains piping. Because it's such a small molecule, it escapes easily. But also under flow conditions, it can ionize easily. And ionized hydrogen is extremely reactive and makes a bit of a mess of metal components. So that's a problem in terms of putting it into the mains. And that's one of the reasons that they're doing the tests of mixed hydrogen and methane to see whether enough can be kept safely in the system. So that's one of the bigger issues. But the other thing is that basically hydrogen as a technology for the future is going to be far more useful for transport issues like big lorries and trains, where electrical supply might not be easy to manage. But for houses, you're losing so much in the inefficiency of producing the hydrogen in the first place by electrolysis, that it's much better to supply the electricity direct to the property.
Thanks. I mean, that really confirms what I was told after the last meeting. It's not something I know an awful lot about, and maybe it would actually be quite an interesting topic for a future, for a future speaker who understands a lot more than I do about the pros and cons of the whole thing. But because the other side of it, as Alan Corbett said earlier on, is also that the boiler companies are trying to promote it at the moment, and I know that there is some kind of test hydrogen project going to be done. I think it's up in the northeast of England somewhere. They're going to be putting hydrogen through the mains somewhere in the Newcastle area to try it out. So maybe there's someone in eco-congregation that knows more than I do about it and could give you a talk on it and could inform us all.
Interesting. Yeah. Good thought for future meeting. We've got a comment from Mark Kirkbride, so I was going to bring Mark in. I wonder if you'd like to unmute Mark.
Yeah, it's an interesting problem with big churches, buildings, relative number of people. I wonder if anyone's tried heated seating, because that's certainly the way electric cars are going, is that basically you don't heat the volume of the car, you just heat the seat. I did find one company that seems to be doing it called Sit and Heat. I wonder if anyone's actually tried it.
Yeah, it was tried in a church at Port of Menteith, I think maybe about 10 years ago. And it was a Czech company that provided the heaters. And it was like, as you describe, it was something really like a you know, an electric blanket, except it was the pew cushion that was used, and basically you switched them on, and I think it worked reasonably well. I don't know how successful it was, and it's not something that has ever gathered much steam. But I think the company that was selling it, I got the impression, without besmirching them, that it was maybe a wee bit Heath Robinson, you know, and it's something that if somebody developed it well, you know, I could see some mileage in it, because it makes a lot of sense. I mean, I don't know about the rest of you, but I've been entertained in people's houses recently where we've been sitting outside to comply with COVID regulations, and you know, people have had electrically heated throws that they're giving you while you're sitting in their garden. So it's a good idea. Good business opportunity for someone.
Okay.
Okay, so we've got a final question tonight, and it comes from David Crippen. So David, I don't know if you can manage to unmute to ask this question, or if you'll need me to ask it for you. I'm hoping you can manage this time. Nope. David was asking about the photovoltaic panels to heat a heat store. What's the advantage compared to solar water panels? And is there a loss of efficiency in using the PV panels in that way?
It's a very good question. I don't honestly know the answer to that. I mean, I suppose the PV panels are more flexible in that you could then use them for other things, like powering the heat pump or powering the light in the church at times when you didn't want to put heat in the heat store. Whereas if you go for a panel which is purely producing hot water, then you don't have that flexibility. You're producing hot water. In terms of the actual relative efficiencies, I don't know the answer to that. I don't know if anyone else does.
I see Andy Maybury's got his hand up. Andy, I'm looking forward to this answer. Thank you.
Yeah. So yeah, really good points. The efficiency of modern PV panels is about 20%. So it's not great. Solar thermal, very much more efficient, but it does depend what temperature you're working at. So to have a solar thermal that goes straight into a heat store that's sitting, 40 to 60 degrees, that works really well. And there's some very nice units, including the Scottish designed solar twin unit. That's good. But you do need to have that low temperature heat store. So the that huge rock thing which is very high temperatures, that's not it's not suitable for that. A unit that we've got down here in Denham Church is a solar thermal air system. So it's like, it looks like one of the water heaters, a flat panel water heater, but it actually heats the air, and so it just runs, continuously through the week whenever the sun shines. But it heats the air, and I mean, I don't know that much about it in detail, but it seems to be very effective, and it's not a total heating solution as far as I understand. But it certainly reduces the cost of their heating significantly.
Mm-hmm. Mm-hmm. Yeah, and it'll produce a good background heat, which will be good in terms of generally heating the fabric a wee bit, which is always good for thermal comfort, because even for a given air temperature, if you go into a church where the walls are a bit warmer, you're more comfortable at 16 degrees, with the walls at 14 than you would be at 16 degrees with the walls at 2. So yeah, I can see the advantage of that. I think I've seen that system as well, actually, Andy, probably in Denham, because I think I've been to your church at some time in the past.
Mm-hmm.
Thank you very much for that helpful additional answer there, Andy. I'm just going to add that the final comment is actually from Jim Smith at Kinross Parish Church, who obviously asked a very important question. If gas boilers are phased out for new installations in 2025, will the cost of heat pumps come down? That's something we've been articulating with the Scottish Government, and it's something they'll be encouraging us to do with churches and wider communities this year as part of the move towards Scotland becoming a net zero nation, that we think that's an important part of what churches can do themselves with their own buildings and in their own communities. And it's also something we've mentioned to the UK government in relation to them being the host of COP26, practical measures that we can take on this year, being a year of climate action, with the climate conference being hosted by the UK in Glasgow. So hopefully the answer to Jim's question is yes, but we've got a lot of pushing to do on this to make it affordable and accessible for all the different church communities. I'm afraid we've run out of time this evening. We went a little bit over like I thought we would, but not too far over. So thanks for staying with us. If you could show your appreciation for Andrew, please. Again, a fantastic evening.
Thanks very much, everyone. Yeah, nice to see you all here. Great.
Thank you very much, Andrew. You're getting a virtual round of applause and a few waved hands through the Zoom box.
Thanks to everyone that helped me with some of the answers. That was great to get some audience participation and help with difficult questions.